Good morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. Today my topic is representing digital images. The digital image fundamentals representing the digital images are under digital image fundamentals. So there are so many types of image fundamentals are there. Elements of visual perception, image sensing and acquisition, sampling and quantization, representing digital images, relationship between pixels, spatial and gray level resolution. Today we are discussing about representing digital images. Already we discussed in the previous classes elements of visual perception, image sensing, sampling and quantization. So today we are going for the representing digital images. So a digital image is represented in the imaging and computer system by numbers in the form of binary digits called bits. Here we see the general structure of a digital images. First it is divided into a matrix of pixels. So each pixel represents a series of bits. An image is a visual representation of something, while a digital image is a binary representation of visual data. Suppose I am taking one image. So this digital image I am representing in the imaging of a computer system by number in the form of binary digits. So binary digit means I am taking as in the form of 110, 110, 11. So total how many bits are there? 8 bits are there. Suppose it is a 16 bit. I am taking as a 16 bit. So it is a binary digit. It is called bits. So what is means? These are called bits. How many means? 8 bits data. Here general structure of a digital image. First it is divided into a matrix of pixels. So suppose I have the image with 128 into 128. So each we are calling as a pixel. Each cell is a pixel. So how many are means 128 into 128 size pixels are there. Each pixel represented in a series of bits. So in the form of computer language, these pixels I am taking as a number of bits. I am taking as a number of bits. Each pixel has the intensity values are there. So these intensity values and the number of pixels we are representing in the computer language as a bits. So that is 8 bit or 60 bit example, whatever it may be. An image is a visual representation of something. Yes, it is. The image is a visual representation and it is a digital image in a binary representation of a visual data. These images can take the form of photographs, graphics and individual video frames. Suppose for the purpose of an image is a picture that was created or copied and stored in electronic form. The representation of an image can take many forms. Most of the time it refers to the way that the conveyed information such as color is coded digitally and how the image is stored. That is how it is structured in the image file. So first of all, I am taking one image. The size is 126 into 126. These images can take the form of photographs and graphics and individual video frames. So there are different forms are there. That is videos, images and photographs. So the purpose of the image is a picture that was created and copied and stored in electronic form. So the representation of an image can take many forms. Most of the time it refers to the way that the conveyed information such as color is coded digitally and how the image is stored and how is structured in the image file. So the image is there. The image in the form of videos or images or in the photos, each have the pixels are there with intensity values are there. So each pixel I am converting as a binary. So it is a form of binary. So this image in the form of color, this image in the form of black and white. So what it may be, we are taking as a color coded digitally and how the image is stored, how is structured in the image file. So the final image is in the form of color. So what is the binary code of the color and how it is stored, where it is storing, what is the restoration technique in that. That is an image file. So image file is, it is an image file. So that is black and white or color. So it is a final binary value. So depends on your binary value, it is a color or black and white. So the final image in the form of color, where it was storing, what is the structure of that image, it will be storing. Okay, where it is storing. So which file it is storing? That is called image file. So image restoration of the file. Next, two elements are required to acquire digital images. The first one is a physical device that is sensitive to the energy radiated by the object we wish to image sensor. The second is called digitizer, is a device for converting the output of the physical sensing device into the form. So there are images I am taking as a analog and digital. So analog is a physical, it is a so the elements are required to acquire the digital images. What are the elements are needed for the digital images for to representing? The first is the physical device that is sensitive to the energy radiated by the object we wish to the image. So analog image, how I am getting the physical means I am using sensor. I am using sensor that is in the form of camera. So I am using camera or sensor. It is a physical device. So the camera or sensor is a physical device. It is capturing the person or image, what it may be, that is in the form of analog, that is a physical. After capturing the image, the image is a digital form. But how we are getting the digital form means with the help of sensors or physical device, there we are getting the soft copy or digital copy, that is a digital image. So the second is called digitizer, is a device for converting the output of the physical sensing device into the digital form. So what is the input for this one? Input is a analog and it is converting to the digital. So digital is the output. So what I am doing? Analog to digital conversion. So analog to digital. So how I am getting analog? What is the source? Physical device or sensor is the source and digital is the output. So this camera, this sensor is captured the image and it is converted to the digital. So sensor is a major role to converting from analog into the digital form. So how we are representing the digital images? How many types of images are there in the representation? So first one is a black and white image, that is a single color plane with a 2-bit. Grayscale image, single color plane with 8-bit. So that is JPG, BMP, etc. And a color image, 3 color planes are there in the 8-bit: RGB, red, green, blue, CMY, YIQ, etc. Indexed color images, that is a single plane that indexes in a color table. Compressed images. So representing images in 5 types. First one we are taking as a black and white image. Second one, grayscale. Third one, color image. Fourth one, indexed color. Fifth one, compressed image. So we are representing in the form of 5, representing black and white image that is in a single color plane with 2 bits. 2 bits means 0 or 1. Black and white means 0 or 1. So if I am taking 0 or 1, white, suppose 0 is a white, then 1 is a black, or 1 is a white, then 0 is a black. Like this. Second one, grayscale image. Grayscale means that is a JPG form or BMP form. It is a 8-bit data. 8-bit means I am taking as a 2 cube equal to 8. So 8-bit data. So grayscale means I am giving some intensity values to the original image with the pixels. Next one is a color image. So color image are the 3 color planes, each of the 8 bits: RGB, CMY, YAQ. These are the color combinations of color image. Next one is an indexed color image. So what is the meaning of indexed color image? So single plane that indexes a color table. Single plane that indexes a color table, that is a indexed. After one is a compressed image. So what is the compressed meaning? Suppose compressed image, my input is a 100 MB image converted to suppose 1 MB data, 1 MB image. Is it possible? Yes, it is possible converting from 100 MB to 1 MB. So I reduced the image size. How means image compression method. I am using compressing image compression method. 100 MB is changed to 1 MB. So what are the advantage? What is the advantage? Means less space, or memory occupied. And another thing means pixels are reduced. So less space memory is required and pixel size are reduced. So these are the advantages of compressing the image. So this compressing the image means 100 MB is converted to 1 MB. So is it changed to 1 MB? Yes, it is changed. 100 MB changed to 1 MB. How it is possible means I'm using compression method to reducing the size. So less memory required. So it is one example of 4 gray level and it is a 2 gray level. So which one is a clarity? So comparative to all those things, 2 gray level is somewhat better. Why? Because 4 gray levels means the brightness is very high. So that is the reason we are not identifying the image. So this 4 gray level I am converting to the 2 gray level. So what is the difference means I am reducing the brightness from the original image. Okay, I am calling as it is an input image and it is an output image. Next, it is one example of representing digital image in the representation form. It is in the 3-bit quantization. So 3-bit quantization. Suppose I am taking one example. How many are there? Here 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it is a 8 by 8 size. So 8 into 8 pixels. So each pixel intensity values are in binary form. So each is the intensity values. So each of the intensity values I'm the intensity values are converted into the 3-bit quantization. So why? Because it is a 8-bit, 8 into 8. So 2 cube equal to 8. So 2 cube equal to 8. So 3 means 3-bit data. It is a 3-bit data. So what is the size means 8 into 8. So that is the reason 2 cube. So 3 power 3. So 3-bit quantization. So it is a 8 into 8 matrix with intensity values are in the form of 3-bit. So those are the intensity values in converting to the binary form. It is another example. Suppose it is a color quantization. Example of 24-bit red, green, blue. So red, green, blue. It is a color combination RGB. How we are getting RGB means in the previous we discussed RGB, CM by YAQ. These are the color combinations are in the color image. So suppose I am taking this particular image or this particular some pixels are there. So these particular pixels I am taking as a zoom. So how many pixels are there? Pixels with intensity. So the color quantization, suppose this animal, I'm taking one example, in this image, I'm taking this part. So I'm taking as a zoom, I'm applying the zoom. So how many pixels are there in this part? So there are so many pixels are there, example, so x into x or x into y pixels. So x into y pixels are there. So what are the intensity values are there? So there are some intensity values are there. So this I am converting to color monitoring. So this image I am converting to the color monitoring with 24-bit color monitor. Is it possible? Yes, it is possible. This white color representation I am converting to the color image or RGB in the form of RGB color image representation in the monitoring. Is it possible? Yes, it is possible in the representation of the digital images. And it is another example of image representation 24-bit red, green, blue RGB representation uncompressed. I'm not compressed this one. So it is so there are different intensity values are there. So 1, 2, 3, 4, 5, 6. So 3 into 6 is there. So here I'm taking 2 by 2, 2 by 2, 2 by 2. So color planes are there. What are the color planes are there? So here red. This is the red, green, blue. So there are random some values are there, red, green, blue like this. Y means I am representing in the form of RGB only. So that is the reason I am taking here RGB, red, green, blue. So it is an uncompressed image. So what are the intensity values of the uncompressed image? So taking one example, 128, 129, 229, 138. So all red values I am taking in one box, all green I am taking in another box, all blue I'm taking it another box. Okay, so I'm dividing as a red, green and blue. So these are the with intensity values I'm dividing that one. So these are the combined RGB combined, but here I'm taking as a RGB. So this is the pixels in the frame buffer. It is a image with x into x pixels, x into y pixels, x into y pixels. So this image I am converting to this one. How we are converting? So RGB, R equal to 8, G equal to 8, B equal to 8. DAC means digital to analog conversion. So it is digital to analog conversion. Translate the digital RGB values into their analog counterparts to be fed to the screen. So the 24 bits associated with each pixel in the frame buffer are split into 3 8 bits groups to specify the pixels red, green and blue RGB components. So the graphical representation of 24-bit true color. So it is one example for graphical representation of 24-bit true color. So it is an input image and it is an output image. So input image is converting to the output with the RGB red, green, blue. So the 24 bits associated with each pixel in the frame buffer are split into 3 8 bits and groups to specify the pixels are in the form of red, green and blue RGB components. It is one example of graphical representation of red, green, blue with input to output. And it is another example, image properties with color. So it is we are using some software. That is example here I am taking some MATLAB. So RGB, I am applying the red, green, blue for the image. Okay. So I am taking what is the method? Histogram method I am using. So how many colors I am using? 271 colors. So how many pixels are there? It is a pixel size. And what are the colors I am using? RGB with the 248, 68, 38. These are the intensity values. And what is the frequency? 38, 68 frequency. 2.4% is there. So in the form of software, it is showing like this. What are the red intensity values? What are the green intensity values? What are the blue are there? So depends on your red, green, blue, the frequency will be changed. So if I'm changing these values, then frequency values also change. So what is the brightness? So I'm adjusting like this. So it is MATLAB one example. So it is an image property with color. And it is a color histogram. You can see here, it is a histogram process applying. So after the output, it is a 3D display. I'm going for the histogram of the original image. So what is the image? 300 into 410 pixels. That is a red, green, blue and 480K. And what is the count means? It is a count and it is a red mean, green mean, blue mean. Okay. So these are the average values. So these are the list. It is a red, green, blue. So what is a red histogram, green histogram and blue histogram? We are dividing as. Actually in this image, all those are combined. But I have to take in the histogram. What are the intensity values of red? What are the intensity values of green? What are the intensity values of blue? So I have to know. So how many are there? Total 262144. So total count. I am dividing as like this. So another some example, image properties in the texture. So what is texture? Small surface structure, either natural or artificial or regular or irregular. So what are the texture examples? Woodworks, knitting patterns. What are the statistical textures analysis? Describes textures as a whole based on specific attributes, regularity and orientation and contrast. So these are all depend on texture. So what is the texture in that one? So small surface I am taking. So that is the structure of the image and either natural or artificial or regular or irregular. So it is a knitting pattern. And what is the statistical texture analysis in the texture? As a whole based on specific attributes, that is in the orientation or in the contrast. So it is another example of texture. So all those are mostly in the black, white and the gray levels are there. So it is almost are in the color form. Okay. So what is the textures? How many textures are there in the color combination? So mostly here using only black, white and gray levels are there. But here there are different colors are there. There are 7 colors I am taking almost. So how we are representing in the color code. So that is the textures of the colors. And types of images. How many types of images are there? There are 3 types of images are there. First one is a binary image. So first one is a binary image. So what is a binary image? It is the simplest type of image. It takes only 2 values, that is black and white, or it is in the form of 0 or 1. Suppose example I am taking 0 is a white, 1 means black. Suppose I am taking 1 equal to black, then 0 is a white. So only there are 2 options are there. One is a white or black, 0 or 1. So the binary images consist of 1-bit image and it takes only 1 binary digit to represent in a pixel. So the binary images consist of 1-bit image and it takes only 1 bit of digital representation of the pixel. Suppose I am taking only 2 by 2 pixels are there. How many pixels are there? 4 pixels are there. In the form of binary representation, 1, 0, 1, 0. Example. So these intensity values of the 1 bit I am representing in the digital form. That is in the form of zeros and ones. And binary images are mostly used for general shapes or outline. For example, optical character recognition. It is one example of binary images with 1 bit. And binary images are generated using the threshold operation. So how we are using threshold? So it is a threshold operation. It is one example. So when a pixel is above the threshold value, then it is turned into the white as 1, and it is below the threshold value, then it is turned into the black value. Suppose I am taking one threshold value here, it is a 1, it is converting to the 0, or another threshold value, it is 0 converted to the 1. So the pixel above the threshold value, so it is turned to 1 means that is white, turned to 0 means black. Another image has a segments into a object and background regions. Okay, every image we are converting to the different segments. Okay, so depends on your image pattern, we are converting to the segments, and one intends to the represent and describes them into the characteristics features for computer processing, and during the pattern recognition of a quantitative course, the efficient storage during the compression. So here every image has in the form of binary, that is in the form of zeros or ones, but every image I am converting to the segments, and every image in the representing of the describing the characteristics features of the computer processing. So every image, it is a quantitative code that efficient storage image in the compression, image compression. I need a in the image compression. So the number of quantization levels, it should be high enough for human perception in the fine shading details in the image. And the occurrence of false counterpart in the main problem is the image which has been quantized with insufficient brightness levels. Okay, so what are the main problems in that? Means when the quantization levels means they are in the form of white and black. Brightness levels are not in balance or insufficient black and white or brightness levels are there. So the number of quantization levels should be high enough for human perception of fine shading details. But we need a sufficient brightness levels we need for the occurrence of false counter in the main problem with the insufficient brightness levels. And there are majorly two types of methods are in image processing. First one is the analog image processing, another one is a digital image processing. So what is the analog image? It is in the form of physical picture. Okay, with the help of sensors, I am capturing the image, that is an analog image, and converting to the physical picture. This physical picture is converting to the digital image. So this analog image I am calling as it is an input, and this digital output I am calling as it is an output. So there are two types are there: analog image processing, digital image processing. So analog is converting to the digital image, it is the ADC. Digital to analog converting is digital to analog conversion. So here analog is a physical picture, physical image is there. Okay, that is I am converting to the soft copy. That is the form of digital image. It is the output. What is input means analog image. And analog image processing can be used for the copies like printouts and photographs. And image analysis use various fundamentals of interpretation while using these visual techniques. The digital image processing techniques help in manipulation of the digital images by using the computers. The three general phases of all types of data have to be undergo while using the digital techniques are pre-processing, enhancement, and display information extraction. So analog image processing can be used for the hard copies like printouts and photographs. So this analog or printouts and hard copies. This image analysis use various fundamentals of interpretation while using these visual techniques. Digital image processing techniques help in manipulation of the digital images by using the computers. The three general phases of all types of data have to be undergo in the digital techniques. What is the pre-processing and display and information extraction. So these are the three types are there. In order to become suitable for digital processing, an image function f of x comma y must be digitized both spatially and in amplitude. Typically, a frame grabber or digitizer is used to sample and quantize the analog video signal. So this analog video signal is converting to the digital signal, that is called a digitizer. The process is called digitizer. How we are means I am using sampling and quantization technique and converting to the analog to the digital. Analog to the digital, that is called the digitizer. Hence, it is order to create an image which is digitized. We need to convert the continuous data into the digital form. Continuous data into the digital form. Continuous means analog data. In the digital form means digital data. There are two steps are there, but that is a sampling and quantization. So sampling and quantization is a major role. So what is the need? Sampling and quantization is need for ADC or DAC. Means analog to digital conversion or digital to analog conversion. So the sampling rate determines the spatial resolution of the digitized image, with the quantization levels determines the number of gray levels in the digitized image. A magnitude of the sampled image is expressed as a digitized value in the image processing. The transition between continuous values of the image function and its digital equivalent is called quantization. And the sampling is a process. What is the use of sampling? The sampling is a process of converting the signals one function to another. So mainly what is the input of means analog image I am taking as a sampling image, that is f of x comma y. So a function, the pre-process is called an analog to digital conversion, that is simply digitization, since an analog image is continuous, not just its coordinates x-axis but also the amplitude of the y-axis. So I am taking one waveform. So this is I am taking as the amplitude, not only the x-axis, I am taking as a y of the amplitude. Y I am taking this one means converting to the analog to digital conversion, digitization of the image. So the digitization sampling is done by the independent variables. In case of equation y equal to sine of x, it is done by x variables. I am taking x only one coordinate. Here I am taking x and y coordinates. So that is the reason I am taking f of x comma y. What is a sampled output? F dash of x comma y. So the quantization is a process of transforming a real valued sampled image to taking a finite number of distinct values. So under the quantization process, the amplitude values of the image are digitized. When you are quantizing an image, you are actually dividing a signal into the quanta. So the samples are converting to the quantization. Quantization means quantized the values or partitions. So a digital signal is a superior to an analog signal because it is more robust or noise and can be easily be covered, corrected and amplified. For this reason, the tendency today is to change an analog signal into the digital signal. So analog to the digital and digital to the analog. Analog to the digital means sampling, quantization. It is a analog image. So ADC means sampling, quantization and the digital output. DAC means digital image, quantization, sampling. What is output means analog image. So in the image fundamentals, we are today discussed representing digital images. How we are representing the digital images means in the form of binary. In the form of binary, we are representing, that is a physical device that is sensitive to the energy, and other one is a digitizer. So physical device is a analog and digitizer means a digital. So using a sensing, the sensing is a capturing the image, that is a analog, and the captured output is a digitizer means a digital image. So how many types of representing of the digital images means black and white, grayscale, color image, indexed color and a compressed image. These are the 5 types. So it is one example of digital image representation in 3-bit quantization. So it is a 8-bit, 8 into 8, 2 cube means 3-bit is possible. So each of the intensities I am taking as a 3-bit. So total 8 into 8 intensities in the form of binary. That is a binary 3-bit quantization. It is a color quantization of 24-bit RGB, red, green, blue. And it is an image representing example 24-bit RGB representation in the uncompressed. So here there are different colors are there, red, green, blue. I am dividing red are different in the form of one group, green is one group and blue is one group. So it is a analog image into the one image is converting to the another image with the help of DAC, digital to analog conversion. What are the color codes are there means AR, GB, R equal to 8, G equal to 8 and B equal to 8. So it is a graphical representation of 24-bit true color. It is another example using some software MATLAB. So how we are taking means what are the intensity values of red, intensity values of green and values of blue And what is the frequency of each intensity? It is a color space and it is a display illumination, number of color cells. So it is a color histogram. It will become, it depends on these values, these intensity values. I am getting the histogram values. So histogram I am dividing as a red, green and blue. So three different histograms here showing. So what are the image properties means? It is in the form of texture, and what are the texture examples and what are the attributes. So these are the texture examples and attributes. So there are two types of images are there. That is a binary image. First one is a binary. It is in the simplest type of image. It is only two values, that is black and white. So 0 and 1. 0 I am taking as a 1 white and 1 is a black. If I am taking 1 equal to black means there is 0 equal to white. So the binary image is generated using threshold operation. Okay, above the threshold the value is 1, below the threshold the value equal to 0. Above the threshold means 1 means I am taking the color is white, below the threshold means the color is black, that is 0. And 1 intended to represent the describing them as a characteristic features of computer processing during pattern recognition or quantitative codes for efficient storage during image compression. Okay, these are the representations. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.